Okay, Unit 5, Objective 4, we look at solving radical equations, and we look at doing that algebraically as well as graphically. So there are kind of two little review boxes here just to make sure we remember how to graph radicals. If you want a video explaining how to graph radicals, look at Unit 5, Objective 3. And then we looked at graphing lines, which we've been doing for ages. But originally we reviewed back in Unit 1, it would have been Objective 2 of Unit 1, if you're kind of wanting to know where else to look for kind of some further demonstration and explanation there. Okay? But solving radical equations algebraically, we've got some recommended steps here. Okay, step 1, we want to start by isolating the radical, or isolating your square root or cube root. And you want to get it so it says this equals a number. Now every once in a while you might have a number still left outside of the radical, and that's okay. You don't actually have to completely isolate it, but the more you isolate it, the more likely it is that you will do the next step correctly. So we recommend isolating it as much as you need to be able to accurately do the next step, which you will see that I pretty much always isolate it completely. Now, in some cases, you will look at your function and you will see that there are actually two radicals in there. So, if there is more than one radical, then you pick one to isolate first. Okay? After you've done that, you're then going to quantity square both sides unless you see that your square root equals a negative number. Then you're just going to write no solution. In some cases, after you've quantity squared both sides, you'll see that there is still a radical there. That would happen sometimes if there's more than one radical to begin with. Although sometimes squaring both sides gets rid of both radicals, so it just kind of depends. Okay? But if in squaring both sides you still end up with a radical, then you repeat steps 1 and 2 if necessary. After you've done that, you're going to isolate your variable or solve using the zero product property. So solving using the zero product property would mean, for example, factoring or quadratic formula, both of which do require you to get your term, or I should say to get your equation to equal 0. And then final thing is you do have to check for extraneous solutions, which means you need to plug your answers back in to check. Now, I know in some classes when you are first learning to solve for x, that last step of plugging back in to check your answer is sometimes stated as an optional thing. You know, it's a good way to make sure you didn't make a mistake, right? With solving radical equations, you have to do this step because there are times as you solve, and you'll see them here, okay? There are times as you solve where you will quote unquote get an answer, but when you plug it in, you discover that actually makes a false statement, and so while it looks like it's an answer, it ends up not actually being one. So this is not an optional step. Okay, this is definitely required here. Okay, and so demonstrating what this looks like. Okay, step 1, isolate our radical. In this case, that would mean subtracting 1 to the other side. Okay. So we have our root 2x plus 1 equals x minus 1. Step 2, we're going to quantity square both sides. Okay, which means this square and square root would cancel, and back here you'd have to FOIL this. X minus 1 times x minus 1 is x squared minus 2x plus 1. You cannot just distribute the squared. You do have to actually FOIL. Okay? Now we're going to solve for x, which means we do need to get this equal to 0 so that we can either factor or do quadratic formula. So subtracting those over, we get 0 equals x squared minus 4x, and 1 minus 1 is 0. And this one I can factor. I can pull out an x, which is my GCF. And we initially get two answers, an answer of 0 and an answer of 4. However, this is where you do have to double check. We need to take these, we need to plug them back in to see, do I actually get a true statement? When I take 0 and plug it in on the right side of the equation, I get 0. When I take 0 and plug it in on the left side of the equation, I get 0 plus 1, which is 1. Square root is still 1. Plus 1 is 2. 2 doesn't equal 0. When I plug 0 in, I get a false statement, so that's not actually an answer. When I plug 4 in, on the right I get 4. On the left I get 8 plus 1, which is 9. Square root, which is 3. Plus 1 is 4. 4 does equal 4, and so my answer is 4. This is what an extraneous solution looks like. 0 is an extraneous solution, one that's not actually an answer. Okay. Okay, so I'm actually going to switch the order of our notes here a little bit. I'm not going to do this 1 and 2 first. We're actually going to turn the page and we're going to practice what we just looked at here a couple of times. Actually, a number of times. Okay? So, starting with number 1, my recommendation, whether it's now or a little bit after, maybe after seeing 1 or 2 more, my recommendation is to pause the video, try the problem on your own. That way you are getting that gauge. Am I actually understanding? Where is my where am I misunderstanding, so I can come into class and specifically ask those questions. It also gives you a gauge of, like, you know, do I need to do another one? Or you could start kind of skipping through the video, finding the problems that you feel like you need extra support on. But you're only going to be able to figure out whether or not you need that extra support if you do actually practice the ones that are there. So again, at some point, whether it's now or later, pause the video, give it a shot on your own, restart it when you're ready. Okay? I'm not going to keep giving that instruction. So from here on out, I'm just going to work through these problems. You need to pause and try at the end of a problem. Okay? Here we go. Number 1, isolating our square root. I'm going to subtract 5 to both sides. And I get 3 root x minus 1 equals 6. I could square both sides right now, but I'm going to go ahead and divide the 3 as well. And so I get root x minus 1 equals 2. Squaring both sides, we get root x minus 1 squared, which is x minus 1, and 2 squared, which is 4. Adding 1, we get x equals 5. You always want to double check that. So taking that 5, plugging it in, we get 5 minus 1 or 4. Square root is 2. Times 3 is 6. Plus 5 is 11. And 11 does equal 11, so I know that's my answer. Okay. Number 2. First, we need to isolate the variable, or isolate the radical. Well, that's done. So now I'm going to square both sides. Square root of x plus 2 squared is x plus 2. X minus 4 quantity squared, if I FOIL that out, would be x squared minus 8x plus 16. Okay, getting this to equal 0, we'd subtract x and 2. So 0 equals x squared minus 9x plus 14. Factoring this equals x minus 7 times x minus 2, which generates 2 initial potential solutions, 7 and 2. It is possible for them to be both answers. It is. But you need to double check. So when I plug in 7, I get root 9, which is 3. Plug in 7. 7 minus 4 is 3. 3 does equal 3, and so I know 7 is an answer. checking 2. I get root 4, which is 2. Plugging in 2 here, I get 2 minus 4, which is negative 2. 2 does not equal negative 2, and so that's an extraneous solution. X equals 7 is my only actual solution. Okay, number 3. Isolate the variable. Isolate the radical. So subtracting 6. You get 2 root x equals negative 2. Again, I actually do know what my answer is at this point, but I'm going to go ahead and continue to isolate. So dividing by 2, we get root x equals negative 1. Right there, when you find yourself with a square root that equals a negative number, your answer is no solution. Now, if you had missed that and squared both sides, and I'm going to white this out. If you had squared both sides, the square of root x would be x, and the square of negative 1 would be 1. You'd get what does look like an answer initially. But when I plug 1 in here, I get root 1, which is 1, times 2, which is 2, plus 6, which is 8. 8 doesn't equal 4. And so that confirms that this actually isn't an answer. It's why, again, it's so important that you actually check your solutions, because you will get numbers that are quote-unquote solutions that end up not actually being solutions when you plug them in. They're extraneous, and so you need to double-check that. Okay, number 4. Isolating the square root, we're going to subtract 3 from both sides. And we get root 17 minus 2x equals x minus 3. Squaring both sides, root 17 minus 2x is 17 minus 2x. And x minus 3 squared, foiling, is x squared minus 6x plus 9. Getting this to equal 0. I'm going to subtract the 17 and add the 2x. We get 0 equals x squared minus 4x minus 8, which doesn't factor. So this would be quadratic formula time. So we have negative b, so that'd be 4, plus or minus radical, b squared, negative 4 squared is 16, minus 4 times 1, which is 4, times negative 8, which is negative 32. So this becomes minus negative 32 or plus 32 all over 2a, which a is 1. So 2 times 1 is 2 there. Okay. This simplifies to 4 plus or minus root 48, which the square root of 48 simplifies because 16 and 3 are 2 factors of 48, and 16 does square root. Square root of 16 is 4, and the 3 would stay behind. And then the 2 can simplify with those 4s to create 2 plus or minus 2 root 3. Now this one's a little bit of a weirder one to test for your extraneous solutions. At least without a calculator it is, so you do have to think very conceptually, very much in signs here. Okay, 2 plus 2 root 3. You can figure out kind of approximately speaking what that is if you would like. You were looking at definitely less than 2 for your root 3. So if you were to say 2, for example, this would be 4, 2 plus 4 is 6. And so you could give kind of an approximation of 6 if you'd like. But you need to keep in mind, like that's not accurate, so it's not going to make a perfect sentence. So what I tend to recommend instead is to think of it this way. 2 plus 2 root 3 is definitely a positive number. When I plug that in, a square root is not going to be negative. If I plugged that in, I'd get a positive. Adding 3 to a positive would still be positive. And 2 plus 2 root 3 on this side, plugged into x, is positive. Does a positive equal a positive? Yes. And so 2 plus 2 root 3 is my solution. 2 minus 2 root 3, on the other hand, 2 root 3 is definitely bigger than 2. So I'm subtracting a number that's bigger from a number that's smaller. So 2 minus 2 root 3 is a negative number. When I plug that in here, I get a positive plus 3, which is a bigger positive. 2 minus 2 root 3 plugged into x, though, is a negative number. And a positive doesn't equal a negative. And so the 2 minus 2 root 3 is an extraneous solution. Okay, number 5. Step 1, isolate the radicals. Well, I have 2 radicals, so I get to choose which one I want to isolate. In this case, root 5x minus 2 already is isolated, so I'm going to say I'm done. Step 2, quantity square both sides. Root 5x minus 2 squared is 5x minus 2. And 2 root x squared, 2 squared is 4, root x squared is x. Okay, subtracting this 4x over, we get x minus 2 equals 0. And so in this case, my x would equal 2. Always good to double check. Plugging 2 in, we get 2 root 2 on the right. And plugging 2 in over here, we get 10 minus 2, or 8. And root 8 is 2 root 2. So we get 2 root 2 equals 2 root 2. So we know we're good to go. Okay. Number 6, isolate the radical. Again, I have 2, so I get to choose which one. Root x is already isolated. It's totally choice. Since I chose to leave it alone in 5, let's go ahead and isolate the other radical in 6. It really does not matter. Okay? If I wanted to choose to isolate this radical instead, I would add the 1 over. Okay? Quantity squaring both sides. Okay, we would have, foiling this out, x plus 2 root x plus 1. And the square and the square root would cancel, giving me x plus 5. Now in this case, my radical didn't go away, so I need to repeat steps 1 and 2. This is an example of when I would want to repeat steps 1 and 2, because I still have a radical there. Okay, so isolating that radical, I'm going to subtract x and subtract 1. So we get 2 root x equals 5 minus 1, which is 4. Dividing by 2, we get root x equals 2. And then squaring both sides, you get x equals 4. Again, it's always good to double check. Make sure you are actually correct. Root 4 plugged in here would be 2. 4 plugged in here would be 9. Square root is 3. Minus 1 is 2. So sure enough, we get 2 equals 2, so we know we got the right answer. Okay, number 7. Isolate the radical. So let's go ahead and add 1 to both sides. We get root 1 minus x equals x plus 1. Okay, step 2, you're going to quantity square both sides. Okay, so square times the square root would cancel, 1 minus x. Foiling this, we have x squared plus 2x plus 1. Getting this to equal 0, we're going to add x and subtract 1 to both sides. And so we get 0 equals x squared plus 3x. This does factor. 0 equals x times x plus 3, which gives me 0 and negative 3. Testing them, when I plug in 0, I get 0 on the right, 1 minus 0, or 1, square root, which is 1, minus 1, which is 0 on the left. 0 does equal 0, so I know 0 is an answer. When I plug in negative 3, I get negative 3 on the right. Negative 3 over here, we get 1 plus 3, which is 4. Square root is 2, minus 1 is 1. 1 does not equal negative 3, so this is not an answer. Okay. Number 8. Isolating the radical, we're going to add 5 to both sides. And so we get x minus 1 to the 2/3. And then to better see this at 2/3, I tend to recommend rewriting the 2/3 as its radical. So the 3 tells us that this is a cube root. I should say the third tells us it's a cube root. And then 2 tells us this is squared. So we can see we haven't quite isolated our radical yet. We do have this squared, so we do need to get rid of the squared by square rooting both sides. And so the square root of 16 is positive 4 and negative 4. Now we have isolated our radical, so in this case we're going to quantity cube both sides to get rid of the cube root. So this is x minus 1 equals 4 cubed is 64. Negative 4 cubed is negative 64. And then adding 1 over, you get x equals 65 and negative 63. Plugging that in, 65 minus 1 is 4. Squared, is 65 minus 1 is 64. Cube root is 4. Squared is 16. Minus 5 is 11. So I know 65 is an answer. Negative 63 minus 1 is negative 64. Cube root is negative 4. Squared is 16. Minus 5 is 11. And so in this case, both are my answers. I don't have an extraneous solution. Okay, 2 more. Numbers 9 and 10. So number 9. We have f of g of x is 5. So g of x is plugged into f. This g of x, 3x minus 2, is plugged into f. And f is root x. So plugging that 3x minus 2 in, this equals 5. Okay, so isolating the radical, done. We're now going to square both sides. We get 3x minus 2 equals 5 squared is 25. Adding 2 to both sides, you get 3x equals 27. And dividing by 3, we get x equals 9. Double checking that that is in fact true. 3 times 9 is 27, minus 2 is 5. The square root of 5 is, 5 is 5. And so this is true when we plug it in. Okay, then one more, number 10. We have f divided by g is 9, so f is x plus 3 to the 3/2. Divided by g, which is 3, is 9. Working on isolating our radical, we're going to start with multiplying by 3. And so we get x plus 3 to the 3/2 equals 27. Again, I recommend, so you can see your radical, rewriting this. The half tells me this is a root, x plus 3. The cubed tells me it's cubed. And that way you can see that to isolate this radical, we're going to have to get rid of that cube, which means cube rooting both sides. The cube root of 27 is 3. Now that we've isolated, we're going to square both sides. Square root and square cancel, so we have x plus 3. Excuse me. And 3 squared is 9. Subtracting 3, we get x equals 6. And double checking that that's true, when I plug in 6, I get 6 plus 3, which is 9. Square root of that is 3. Cubed is 27. Divided by 3 is, in fact, 9. And so I know that's my answer. Okay? Before we hit that last piece, let's go ahead and take a look back at the number 1 and number 2 that we skipped originally. Okay. So we'll do number 1 together, and then number 2 you can try on your own. Okay, so number 1, solving algebraically, we're going to start with isolating our radical. It's already isolated, so I'm going to quantity square both sides. Square and the square root cancel. And negative 2x squared, negative 2 squared is 4, x squared is x squared. Subtracting the x, subtracting the 5, we get 0 equals 4x squared minus x minus 5. Okay. This does factor. Excuse me, sorry. So this does factor to 4x minus 5 times x plus 1, which gives me two initial solutions of 5/4 and negative 1. Okay, plugging those in, when I plug 5/4 in, I get negative 5/2 on the right. Plugging 5/4 in here, we get 5/4 plus 20/4, which is 25/4. Square root is 5/2. Well, 5/2 doesn't equal negative 5/2, so that's not actually an answer. Plugging in negative 1, we get 2 on the right, and on the left, negative 1 plus 5 is 4, square root is 2. So my answer is negative 1. B is the new bit, okay, which is we can find this answer by graphing it, and we looked at this in a prior unit. If we were to graph this root x plus 5 and graph this negative 2x, we'd see that they touched at negative 1. Okay, so graphing our root x plus 5, my hk in this case, pulling out my h would be negative 5, my k would be 0. And then plugging in numbers, you can plug in whatever numbers you want, but I would probably recommend plugging in negative 4, because then you get root 1. And plugging in maybe negative 1, because then you'd get root 4, which is 2. And one more for good measure, maybe plugging in 4, because then you get root 9, which is 3. And it gives you a nice little sketch of your radical. Again, if you want a more detailed explanation of graphing radicals, look back at Unit 5, Objective 3. Okay, this linear equation starts at 0, 0, so at my origin, and then goes down 2 over 1, down 2 over 1, because my slope is negative 2, or up to left 1 if you prefer to go that direction. And when you graph this line, we see that sure enough, these two functions, my root x plus 5 and my negative 2x, do intersect at x equals negative 1 here. Okay, so go ahead and pause the video, give number 2 a shot on your own, restart it when you're ready. Okay. Algebraically, isolating our radical, we're going to divide that negative over to the other side, so we get negative x plus 4. Quantity squaring both sides, we get our square and square root cancel, so x minus 2 equals. Foiling this out, negative x times x is x squared. Negative x times 4 is twice is negative 8x, and 4 times 4 is 16. So that'd be foiling out that negative x plus 4. Subtracting the x and adding the 2 over, we get 0 equals x squared minus 9x plus 18, which factors to x minus 3 times x minus 6. Two initial solutions then of 3 and 6. When I plug in 3, I get negative 1 on the right. 3 minus 2 is 1. Root 1 is 1 times the negative is negative 1. So we get negative 1 equals negative 1. That means 3 is one of my answers. The question is 6 also? When I plug in 6, I get 2 on the right. On the left, I get 6 minus 2, which is 4. Square root is 2. times a negative is -2. -2 doesn't equal 2, and so this one's not an answer. It's an extraneous solution. And then graphing it, we'll go ahead and graph our negative root x minus 2 and our x minus 4. Okay, my HK for this radical would be 2, 0. And plugging in additional points, I might recommend plugging in 3, because then you get root 1, or 1 times a negative is -1. And plugging in maybe 6, because then you get 6 minus 2, which is 4. Root 4 is 2 times a negative is -2. And you get this graph here. This point, or this function, starts at the point 4, 0, and then has a slope of 1. So we're going up 1 over 1, up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. I just realized you might also think of this as starting at 0, -4. For those who think of this as your y-intercept, because it is your y-intercept. So you might think of it that way, if you prefer. Still generates the same graph. And we can see that these two functions do intersect at 3. Okay, the last bit of objective 4 was looking at domain restrictions. Okay. So we have a function is undefined for values of x not in the domain of a function. This occurs when you are dividing by 0 or the square root of negative values. So dividing by 0, what that means for us within our work is we are going to look at where does the denominator equal 0. Because anything that makes the denominator equal 0 will be outside of our domain. Okay, the square root of negative values. What does that mean for us? It means where we are going to find where our square root equals 0. Not because that point is outside of my domain, but because the intervals might be. And so after you find those points where the radical equals 0, you're going to test your intervals, like the number line test from a couple of units ago, to see do any of those intervals result in a negative region. Because if it results in a negative region, then we're done, right? That part is outside of my domain. Okay? And so here we go. Finding the domain of each of the following functions analytically, we're going to write our answer in interval notation. Okay, so in this case, number 1, if we were to look at this square root, there's no denominator, so I don't need to worry about this piece, but the square root could have negative regions, so I need to find out where does my square root equal 0, which means I need to factor. Okay, as I look at this function, x squared factors out. We'd be left with x squared minus 9x plus 14. This further factors. The x squared would stay, but that x squared minus 9x plus 14 factors to x minus 7, x minus 2. And so I have 3 values that make this, this square root equal 0, which again, they are not the issue. A square root can equal 0. A denominator can't. I should maybe put doesn't equal 0. Okay, but a denominator can't equal 0. A square root can equal 0. Square root of 0 is 0. The issue would be in between those numbers, and so my values are 0, 7, and 2. When I put those on my number line, those ones are points. It's the in-between that might not be. And so when I take a number, say less than 0, and I plug it into my square root here, because then that's the piece that can't equal 0. Okay, if I take a number like -2 and plug it in, what I get is a positive times a negative, which is positive. So that region I like. When I take a region like 1 between 0 and 2 and I plug that in, I get a positive times a negative, which is positive. Good to go. When I take a number between 2 and 7 though, like 5, I get positive times negative times positive, which is a negative region. And so that space there between 2 and 7 is outside of my domain because it makes my absolute, I just keep saying absolute value, I'm sorry, makes my square root equal a negative number. And we can't have a negative under the square root. That's imaginary. Okay, right of 7, like 9, I get positive, positive, positive. And so that region's good to go. And so my answer is negative infinity to, I don't have to cut at 0 because it is a point. If this was a hole, I'd have to cut it there. All the way to 2. And that's a bracket because there's a point there. And then 7 to infinity. Okay. Doing one more here, and then I'm going to recommend that you pause the video and give it a shot and restart it when you're ready. We're going to do number 3 together next. I'm actually going to modify number 3. I'm going to make it root x minus 4 over x squared plus 16. Okay. So, number 3, we do have a denominator here. So I would need to figure out, okay, what would make this denominator equal 0? Because those would need to be holes in my interval. However, x squared plus 16 doesn't ever equal 0. So I'm good to go. Next up, what would make my radical equal 0? Well, my radical would equal 0 at 4. And so again, the 4 isn't the issue. A radical can be 0. That's not a problem. It's the interval that might be an issue. And so I'm going to test a number left of 4. And I'm only going to test it in the radical. The reason why is a denominator can be negative. Sure, it's just a negative denominator. And a denominator can be positive. Just a positive denominator. A denominator in and of itself doesn't really matter. It's a root that can't be negative. I can't square root a negative number. And so when I take a number left of here, say 0, and I plug it in, I get 0 minus 4, which is negative 4. I can't square root a negative. And so that region is an issue. When I take a number like 5 and plug it in, well, then I get a positive 1 underneath the root. Well, that's good to go. I like that region. And again, denominator could be whatever it wants to be. Unless the denominator is a root, then the denominator can't be negative. But the issue is the square root when it comes to the testing. Denominators, the only thing we have to worry about with denominators is if there's a hole in my domain. Okay, so for this domain, we're going from 4 to infinity. Okay, so my recommendation then is to try number 2 next. So pause the video, give number 2 a shot, restart it when you're ready. And then do number 4. Again, pause the video, restart it when you're ready. Okay, so number 2. Okay, number 2, we don't even have a root to worry about. That's nice, so I don't care about sign at all. I do care about my denominator though here. So if I factor this, this becomes 3x plus 1 and x minus 5, which gives me 2 values for my number line here. 1 at negative 1/3, 1 at 5. What makes this one nice is that because those in the denominators, those are going to be holes, but again, there's no root. So I don't care if it's negative or positive in between. Fractions can be whatever sign I want them to be. Denominators can be positive, numerators can be negative, doesn't matter. It's just the root that can't be negative. And so in that case, this one's actually a little bit easier because I've already got my intervals. Negative infinity to negative 1/3. Negative 1/3 to 5, and 5 to infinity. Okay. And then last but not least, go ahead and pause the video, give number 4 a shot, restart it when you're ready. Okay, number 4, we have a double hit here. We've got our root, which needs to be on the number line, and we've got a denominator. This denominator factors to x minus 7 times x minus 1. So there are 3 numbers going on my number line. 1, 3, and 7. 1 and 7 are wholes because they come from my denominator. 3 makes my root equal 0, which is in the numerator. That's okay. My numerator can equal 0. So that's a point. Testing your intervals then, because again, we do actually care. Now, one more time, we don't care about the denominator. All I care about is the root going to be negative? That's my issue there. So if I take a number like 0 and plug it in, I get root negative 3. Well, I can't have a negative under the root, and so that's outside my domain. When I take 2 and plug it in, I get root negative 1. Again, I can't have a negative. That's outside my domain. When I plug in 5, I get root 2. Well, I like that one. Root 2 is fine. And when I plug in 9, I get root 6, also positive. So we're good to go with that region. So my domain is from 3 bracket to 7 parenthesis and 7 parenthesis to infinity. Infinity, remember, is always parenthesis. Okay? And that's objective 4.